Morning, Jed.
Morning, Luke. Morning, everybody.
Thank you very much for joining us. Week 2 on machining. Just very briefly, introduce yourself.
Yes, sure. My name's Ged Maloney. I'm National Technical Manager at Lights Tooling UK. For those of you who don't know me, most of you do, I think. And amongst my responsibilities is window and door production, solid timber applications.
Awesome. So, moving on swiftly from last week where we were discussing preparation, planing, and prep for machining, could you sort of let me know how that follows on into this week for profiling?
Yeah, sure. Last week we did talk about some sawmill applications, which are not our world, but let's not forget that we do deal with the products that the sawmills turn out. So dealing with the surface preparation from planing all round is important because, as I said last week, some of those surfaces are not touched again through the process of production. So there's no profiling done to them. They are a finished surface, so that's why that's important. But also what's important when it comes to the profiling is the dimensions that are produced. If we've got critical dimensions of, for example, 93 millimeters and 57 millimeters, and having those accurately machined is important because it makes the profiling follow along very naturally. It can have a detrimental effect on your profile machining, whether it's cross grain or along the grain, if those dimensions are inaccurate. So that's how it follows on.
Cool. So, are the principles the same in planing and prep as to profiling in regards to like pitch marks that you mentioned?
Yes, absolutely. The same cutting principles apply. So the pitch marks, I'm going to just bring that diagram up again. The pitch marks that we discussed last week will be produced again. There we are. It will be produced again when we're profiling along the grain. So we're looking at trying to achieve that area between 1.3 and 1.7 in joinery production. And that will give us an excellent finish and a finish that can go straight to spray, which is our aim. So the same principles apply, the same parameters apply, and the same contributory factors apply. So we've got the RPM of the tool combined with the diameter of the tool, combined with the feed speed of the workpiece, the material. They all combine to make those pitch marks that we were just looking at.
Sure. Okay. So let's get on to some of the features on the lignum tooling. Can you explain some of those features on the actual lights lignum tools in regards to where you're profiling through the timber?
Yeah, the lignum tools, very much like Owen's design of the lignum window itself, the lignum profile cut Q tools from Lights have got features, all of which are there for a reason. I'm going to just go back to share my screen if I may.
Absolutely.
Just give us a second. The way the tools are designed, we have several features, all of which benefit the surface preparation and the ease of use for the machine operator. If you look at the bullet points on the right are to prompt me, but screws being clamping screws behind the knife. If I use my pointer here, that screws just is clamping that knife in. The advantage of that is that the gullets remain clear. That's where all the resin's going to build up. And if the screws were in there, they get clogged up with resin. They're difficult to get out. You finish up rounding them off and the knives never get changed. And that's often why people overrun tools, because they just can't get the knives out. a small feature of triangular spurs. If you will have all seen tools with square spurs on the top and bottom of them, and what that design does is it just actually scores the surface a little bit like a saw blade might, whereas a triangular one, the leading edge of that triangular spur actually planes the surface. So if we think about a simple profile like a rebate, the short section of the rebate is still a good enough finish to go straight to spray, even though in our design it may well be covered with glass, or it might be covered by weather strips. It's still important that that surface is a good one. The knife seatings are worth mentioning. The profile knives here on the tool on the outside that create the ovalo mold, for example, or the Euro groove, they cannot be positioned incorrectly. They've got datums axially and radially, so that even an inexperienced operator can't position the knives incorrectly. And the way that they're clamped means that they're going back in the same place every time. If you think about trying to position knives like this, the ones on the top left of your screen, that design of knife fits over pins. We'll have all seen that in tools over the years, but there's a big tolerance between those holes and the pins themselves. And the truth is, those knives, that type of knife never goes in the same place twice, and it introduces tolerances. Whereas the design on the right, as that's clamped up, you can see the slight V shape of the groove that positions it. As that's tightened up, it's going back in the same place. And what we're doing with this tooling is we're chasing down tolerances. We're minimizing tolerances, every little bit of it. So going back to the image of the tool, the material that it's made of is a lightweight alloy. It's not aluminium as such, but it's an alloy. That means it's putting less strain on the machine. It's putting less strain on the bearings because of its lightweight. And the acute balancing that I refer to there, again, brings it treats the machine with respect. We're not putting a load of strain on the bearings, and particularly important when we're talking about the tenoning and slotting tools, which are of a big diameter. So we've got big chunks of tools here of this design, and would be the RPM for that tool would be 8,000 more than likely, ideally. And you'll have all seen demonstrations by me and Owen over the last couple of years, and those tools run very, very, very quietly. The advantage of quiet running is not just a good working environment, it means that the vibrations are minimized. And that again gives us better surface quality. The straight knives that I spoke about earlier are reversible. The profile ones are not. They're just throw away and replaced. But the material that they're made of means that that's not done very often. We do have customers who've had these knives in a couple of years, literally a couple of years, and then it's changing. So we're not talking about having to strip them down every month. It's not that kind of system. The marathon coating that's applied makes the knives look yellow. You can just see that on some of these peripheral knives here. And that coating, it's a secret recipe, a KFC job, but it allows extreme knife life. It adds, we estimate, 3 to 4 times what it would be if it's not coated.
Perfect. So
the other thing, Luke, one more thing is
sure.
that the tools you can see on this image, that we've got 3 discs, and we assemble those on a sleeve, and again we're chasing the tolerances down. If you think of all those sleeves being put straight onto the shaft of a spindle molder, there's a great chance of them all running eccentric to each other, whereas assembling them on a sleeve means that we've chased that down to one tolerance. There's got to be the tolerance between the sleeve and the shaft, but that's the only one we've got.
Sure. Okay. So that brings us nicely on to talk about setup and changing tools. Obviously, the Lights Lignum tool set is 0 set. So just talk us through that and the advantages, please.
Yeah, when we describe the tooling as 0 set, what we're talking about there is between profiles. So Owen and I have set these machines up for customers regularly in the last couple of years, and once the datums are set, they're set for every tool. So let's stick with the profiling for the time being. The datums we're talking about here are the fence and the bed, and the tools are set -5 from the bed straight across the board, and the minimum diameter of the tools, like the image we were looking at, is 140 millimeters. So once the fence and the height of the shaft are set, when you go from, let's say, putting the glazing profile on the casement or the sash to putting the outer profile on the casement or the sash, we undo the nut, remove the tool, put the next tool on, fasten it on, and away we go. There's no need for a test cut. You can be 100% sure that the tool is in the right place. So on the profile tools, as I said, -5, that's where the bottom of the sleeve hits the bottom of the shaft, if you like, the spacer on the shaft. And the minimum diameter when we're talking about profiling is 140. So that's the part of the section where the least is cut off, and as the rebate grows or the section gets deeper, the tool gets bigger. When you talk about the scribing or the tenoning, if you like, that works in the opposite direction, and the datum there is the maximum diameter of those tools, which is 320 millimeters. The same principle applies with the height. So if you're using a spindle molder, as we often do, where tenoning and slotting is done on a carriage using the same shaft, the shaft is in the right place. We only have to set a datum as a stop so that our cross grain work is stopped in the right place.
And then every tool on and off that's where it's set. So,
it's absolutely, it's set. That's right. So there's no movement of the shaft. There's no movement of the fence. There's no movement of the tenoning tools. The depth of the tenon is determined by a stop, just like it would be if you were using on a Vertonghen or an old-fashioned machine like a Wadkin or a Robinson or that type. You would always have a stop, either a shoulder stop or a length stop at the other end. So there's no difference in that respect. And there's enough room. The reason for 320, these are big tools again. The RPM for them, by the way, would be 4,500, and they run very, very quietly. The acute balance on these tools is very important when it comes to them. The reason they're so big is so that we can get the door style section between the edge of the tool and the sleeve. It allows us to get between 110 and 115 millimeters of finish section for our door styles.
Sure. And what about some of my customers I know use HSKs? We discussed this the other week. So what's the added advantage of that?
Well, the advantage of an HSK interface on a spindle molder is that it is slightly quicker to change the tools than undoing the nut on the shaft, because it is just pressing a button and releasing the interface, taking the tool off and putting another tool on. It's marginally quicker, but the truth is that a machine as sophisticated as that isn't really necessary because of the 0 setting. So as long as the motor's a minimum of 7.5 kilowatts, preferably 10 kilowatts, so it's man enough, that the machine will be good enough to do it. people have got machines with computer programming screens where you can just program it in, and the shaft and the fence moves accordingly. Again, it's a great feature of a machine, but it's not absolutely necessary because of the zero setting of the tools.
Perfect. And special profiles or offline, how do we deal with that?
Yeah, we touched on this at the end of last week, and there are some profiles that could be produced very effectively on four-side machines, some four-side planers with an adapted tool, or if there's a fifth or sixth shaft on them, sill section and rain head section are good examples of it. The tools could be of the design like we've been looking at in the images, or they could be more flexible, the type where you might describe them as universal. If we think about profiling on the spindle molder, again, Lights offers, I always like to refer to it as a league table, and at the Champions League end of this is the Profil Cut Q tools, but they are dedicated, so there's limited flexibility. But there's also universal type tools that have got carbide knives as well. So if you wanted more flexibility, there are solutions for that. We call it Veriform. It's a very good system. I should add that there is some flexibility on the tools for the mold. I didn't mention at the time, but if, for example, your customers didn't fancy the Ovlo mold, that's the most common, there's an option to change the knife. There's no tool change, it's just a knife change to a bevel or a lamb's tongue design. That's just a feature built into the tooling itself. A good example of offline profiling is the horn profile. I think the horn profile on vertical sliding sash windows can be, having made plenty of them in the past, it can be a bit of a nuisance doing it on a bandsaw or a router, and it involves an awful lot of sanding to get that surface anything like good enough. There's an excellently designed tool that we can use for that, and the finish of it is phenomenal considering that it's cutting cross grain. It's an excellent example. Such tools could be used if you've got CNC facilities. The axis can be turned and used to go across them, but another good application of it is to use it on the horizontal spindles of a tenon, whether that's a modern machine such as a Tongan. Could take the tenoning head off and put this on it. So your timber's running along the tenoner, either under the top one or over the bottom one. It can be done both ways. And another way that can be done is you could dedicate an older traditional type tenoner to that process. So the machine that I mentioned a few minutes ago, such as a Wadkin or a Robinson type machine, they can produce an excellent finish as well.
Perfect. Well, I'm not letting you get away with it. You set it up. You set it up. So come on, Alfonso the dancer.
Ah, dear. I was up all night. Not worried about what I've just been talking about, knowing that you were going to ask me that. I've said to you and Teresa before, the name it's designed to intrigue, and if I explain myself, the intrigue will drop. If you organise a Christmas party, I'll demonstrate why I'm called that.
Okay, well, I'll just quickly share my screen quickly because if I can find it, let me find it. I've done a bit of digging, so here's an old picture that I found. We'll leave it there.
Yeah, please do.
All right. Thank you very much indeed for joining us, Ged. And we'll go back to the floor. Cheers, bud.